In this video, we're going to talk about our first parsing algorithm, recursive descent parsing. So recursive descent is what is called a top-down parsing algorithm. And you might suspect that there are also bottom-up parsing algorithms, and there are indeed such things, and we'll be talking about them later. But in a top-down parsing algorithm, the parse tree is constructed from the top, so starting with the root node, and from left to right. And so the terminals then will be seen in the order that they appear in the token stream. So for example, if I have this token stream here, this is a hypothetical parse tree that I could construct, and the numbers here correspond to the order in which the nodes of this parse tree are constructed. So we have to begin at the roots. That's the first thing that happens. And then if T2 is belongs here in the parse tree, that'll be the next thing that happens. But then if we have a non-terminal in the next position, that will be number 3. And then if that has children, well, the leftmost one, so because we're going left to right, will be the 4th thing to be generated. And then let's say that the 2 children of number 4 are both terminals, so that will be the next 2 terminals in the input, and so on. The next thing that will happen is the second child of number 3, and then the last 2 terminals appearing in left to right order. So let's consider this grammar for integer expressions. And let's look at a particular input, a very simple one, just open paren 5, close paren. And now what we're going to do is we're going to parse this using a recursive descent strategy. I'm not going to actually show you any pseudocode or anything like that. I'm just going to walk through how this input string would be parsed by using this grammar and the recursive descent algorithm. And the basic idea is that we begin with a non-terminal, begin with the root node, and we always try the rules for a non-terminal in order. So we will begin by starting with e goes to t, and if that doesn't work, we'll try e goes to t plus e. So this is going to be a top-down algorithm beginning at the root. We're going to work from left to right. We try the productions in order, and when the productions fail, we may have to do some backtracking in order to try alternative productions. There are 3 parts. There's the grammar that we're using. There's the parse tree that we're building, and initially that's just the root of the parse tree e. And finally, there's the input that we're processing. And we'll indicate our position in the input, how much of the input we have read by this big fat red arrow, and it always points to the next terminal symbol to be read, the next token to be read. So in this case, we're starting with an open paren. Okay? And also in the grammar, you can see the highlighting here, the brighter red color indicates which production we're going to try. So we're going to begin to build our parse tree by trying the production e goes to t. And what does that mean? Well, that means we make t the child of e, and then we continue trying to build the parse tree. Well, so remember we're going left to right and top down. So now t is an unexpanded non-terminal. It's the only unexpanded non-terminal, so we have to work on it. And what are we going to do? Well, we're going to try a production for t, and since we haven't tried any yet, we'll just try the first one. T goes to int. So the next step is to make int a child of t, and that's what our parse tree looks like. And now we actually have something that we can check. We can check whether we're making progress. So observe that as long as we're generating non-terminals, we don't really know whether we're on the right track or not. We have no way to check whether the non-terminals that we're generating are going to produce the input string. But once we generate a terminal symbol, then we can compare that with the next input token to see if they're the same. And in this case, unfortunately, they're not. So the int that we generated here doesn't match the open paren in the input. And so clearly, this parsing strategy, or this parse tree that we're building, isn't going to work out. So what we're going to have to do is we're going to have to backtrack. That means we're going to undo one or more of our decisions. We're going to go back to our last decision point and see if there's another alternative to try. So what was the last decision we made? Well, we decided to use t goes to int. So we can undo that, and then we can try the next production for t. And that happens to be t goes to int times t. So we'll expand t using that production. And now, once again, we've generated a terminal in the leftmost position. And so now we're able to compare that with the input. And once again, unfortunately, the int token does not match the open paren, so we have to backtrack again. So we undo that decision. Okay, this takes us back to trying alternatives for t. There's one more possibility, and that's that t goes to open paren e close paren. So we expand t using that production. And now we can compare the token open paren with this open paren with the open paren in the input, and they match. And so that's good. That means that we might be on the right track. And since they match, anything that we do in the future is going to have to match the different input, and so we'll advance the input pointer. So now, what are we going to work on next? Well, we have to expand this non-terminal e, and we're going to do the same thing we did before. We're just going to start with the first production. So we have e goes to t, and then we have to work on t, so we're going to pick the first production for t, and we have t goes to int. And now we can compare. Is int matching int in the input? And indeed it does, and so we advance the input pointer again. And now we're here, and what's left? Well, we've progressed to this point. We're looking at that open paren, and that also matches. So that matches the input, and now we've matched everything in the parse tree, and our input pointer is at the end of the string. And so this is actually a successful parse of the input expression, of the input string. And so that means that we accept, and the parser terminates successfully.